Thanks to Chris, we can get our hands on one of these newest and currently in use model generators, which should be the most fuel efficient out of anything I've ever tested. So I'm thrilled that Chris is gonna let us test this one and see just how many kilowatt hours we can put into a battery bank per 1 gallon of diesel fuel. So here we go. Hi everyone, I'm David. Welcome to my channel. I'm actually visiting Chris at his off-grid home site right now where he fixes up these generators. But this particular generator is very special. So please tell me more about this one.
So this generator is a MAP 1030, and this represents the currently deployed equipment that the military is using. These are smaller, they're more fuel efficient, they're made by Cummins Power, and they are supposed to basically bring another level of reliability to the battlefield, is what the promise was on these. They also have some really fun features. You can parallel these generators. So if you need 5 kilowatts, you run one. If you need 10, you can put two 5 kWs together and run them together instead of having to have a 10 kW generator. So you have more options, and it's almost like Lego. You put it together, however much you need, however much power you have is how many of these you put together.
What engine are they running in this generator?
So this generator uses a Kubota 3-cylinder liquid-cooled diesel engine that is very similar to the engines that John Deere tractors run and a lot of other power equipment. So this is a well-known and a very high reliability engine that's been around for a long time.
And what RPM?
So this is 1800 RPM, so it's going to be low speed, low noise, low vibration.
Can you tell me about the generator head?
So the generator head on this is very similar to the generator head on the previous generation. It's a 12-wire head, so it can be wired for single phase, 3-phase, or split phase. So it can do all three. It can do single phase 120, it can do split phase 120, 240, and it can do 3-phase 208.
All right, Chris, what's on the back side?
So this side of the generator is pretty much just maintenance. The engine is just inside the wall here. This plate comes off and allows you to service the accessories on the front of the engine, change the belt, alternator, those kind of things. We also have the electrical port here for jump starting the machine if you needed to. And down here is your ground rod storage. Okay, on this side, we have one of our compartments to access the engine bay. On this side, we've got our phase selector switch over here, which lets you change it from, say, 208 3-phase to 120 240 single phase, split phase. And we also have the switch down here to disable the electrical inside the control cabinet that we'll look at in a moment. So over here, we've got fuel filter, we've got the air filter up top, and we have the engine itself.
And the storage compartment?
Yeah, in the storage compartment here, this has the fuel hose, which, as we were joking earlier, almost never comes with these. They always get stripped out before they go to auction.
Okay, next panel.
So the next compartment here, this is where you connect your power. And so they've done something a little different in this one, where you actually have to open the door and then lift this other cover before you have access to the terminals. So they added another layer of safety. And there's actually a switch on this so that if this is not closed all the way where you have it in a safe position, it actually gives you a warning on the display. So on this side of the machine, we have the convenience electrical outlet here. We have your power outlet here. In this compartment, we have the fuel tank and the main computer that runs the engine and the fuel pumps and all that stuff. Here on this side, this is the fuel neck for adding fuel. And then under here is the control panel. So this one, again, is very different than the previous generation because this is actually computer controlled. So once this unit is running, the computer does all the work as far as making sure that the RPMs and the voltages and everything are set. Could be good, could be bad, because if the computer goes out, then you've got nothing. But on this one, there's no knobs to twiddle for RPM or voltage. It's all preset in the computer. And on the final side of the machine, we've got our air intake for our cooling system. And we also have the other side of the engine, which has the alternator, the batteries, and the exhaust over here. So not a lot to see, but Yeah, just pretty much where the work happens.
Why are there 2 batteries?
Yeah, so these units run on 24 volts, so the 2 batteries are in series. And so that just lets them use smaller wire and everything, just a more efficient cranking system. And that's the standard for the military. Everything's 24 volts.
Okay.
So here we have another storage compartment, and this one includes some cheat sheets and also all the data cables in case you need to parallel the units or get some data out of them onto a laptop. So this has that capability as well.
You and I were just reading the manual on this, and what did the manual say the fuel economy of this unit was?
Yeah, so it said the fuel burn at its full 5 kW rated output is 0.39 gallons per hour.
Which is incredible, and that translates to 12.8 kilowatt hours per gallon.
Yeah, this would be hands down far more efficient than anything you've tested so far if it comes out to that.
Now, I've tested the charge inverters on my channel before, and generally we're talking about 90% efficient.
Yeah.
So if the charge inverter is 90% efficient, this does 12.8, that means we should get about 11.5 kilowatt hours per gallon into the battery bank.
Yeah, I think we should find out.
Now, I'm not sure we're actually going to get that high because usually these things are tested under like really great conditions, and we never match that, but it still should be better than anything I've tested on this channel before. Now, we've already heated this engine up.
Yep, it's warm, ready to go.
Now, the fuel tank is a little bit more complicated and tight. It's very difficult to get to. So we are going to take a little different approach. Instead of using this auxiliary tank.
Yeah, auxiliary tank.
Yeah. Instead of using the auxiliary tank, which I've used in previous videos, we are going to mark the fuel tank. We'll run this for about 2 hours, which should be about 1 gallon. And then we will use this to measure exactly how much fuel we put back into the tank, bring the level back up to where we marked it.
Yep, sounds reasonable to me.
These are really beautiful units, and they're hard to get to, and they do cost a premium, don't they?
They really do. In general, they cost about double or triple what the previous generation generators go for.
Wow, double or triple?
Yeah.
So I'm not sure it would justify just in fuel economy.
No, no. I actually started getting a couple of these since I knew that this is what was coming in the future. I wanted to make sure I understood them before I started buying them at auction to resell, because I never want anyone to take something home that is going to be an unknown quantity.
Okay.
So these really, I got these so that I could learn more about them.
Well, they look awesome, and these are even new for me. These, even though they're currently deployed, I was always running the 802 and the 803 models when I was in. So these are just beautiful units. Can you actually get these at auction?
You can. They do come up occasionally. I ended up getting 3 of them, so I do have 3. So you can get them. You just have to be prepared to go up against some people who really want them bad when it comes to what you're going to pay for them.
Well, I think I'm going to stick with my 802 for the time being, but I don't know. I mean, depending on how efficient this thing is, it's going to be very tempting.
Yeah, it would be, yeah.
So let's bring the camera around. We're going to check out the fuel tank and make a little mark on there for our current fuel level. Chris, we're about to mark the fuel tank, right?
That's right. So we're going to put a mark here to show where the fuel currently is. Since this is a translucent tank, we can see it. And in addition, the fuel sensor in here is an ultrasonic distance sensor, and it reads out in 1% increments. So we're going to compare the fuel sender to the mark to make sure that we have the best possible measurement.
And is an ultrasonic sensor more accurate than a float?
Yeah, this is a situation where I think the ultrasonic is much more accurate than a float, since we do get a 1% readout here per the tank level, and we don't have any of that ambiguity with an analog float that you can have.
Does the unit have to be running?
No, we can take fuel measurements without the unit running.
So here's our mark on the fuel tank, and let's see what the ultrasonic unit is reading. 100%.
Yep. A generator so easy to use, even David could do it.
Well, let's start it up, and after a few seconds, we're going to be able to close the output circuit and go over to the charge inverter and make sure that we're charging the battery. So this unit is much quieter than the 802. And notice that I didn't have to wait for the glow plugs, and I didn't have to hold it in the start position. The unit does that automatically. Chris, are we good to go?
So once it revs up, you can turn it on.
All right.
Not yet.
Where's the revs on this one?
You'll hear it rev up.
Oh, okay, so we're at a very low idle.
Yeah.
Okay, so we're at
doing self-checks right now.
So the internal computer is doing some self-checks right now. It just revved up. And now I've got 120 volts.
Yep, you can hit the button anytime.
All right.
Yep, you get now we're showing 120 on the output.
I heard the relay click. Let's go over to the charge inverter. The charge inverter's running. Let's close the circuit breaker on it. And now we'll come to the screen and we'll need to make sure it's running at 100 amps. Okay, so we're at 100 amps. And we'll do our timer. So in this case, we're just going to run it for a solid 2 hours, shut it off, and then refill the fuel tank. In this case, it says that we're actually outputting 5.7 kilowatts over to the charge inverter. Is that too high, Chris, or can we do that?
Let's see what happens. I'm curious to know myself.
All right, so we're going to try to run it for 2 hours, overloaded at 5.7 kilowatts. We can always add more fuel if this doesn't work out. Oh, we're getting a warning.
Yep.
We're overloading here, so let's turn it down.
Yeah, we need to back it down just a little bit.
So we're at 90 amps, and let's go back over to the unit. All right, still says overloaded 5.1.
Yeah, hit the fault reset a couple more times. It's yellow, so it's only a warning, so it's not a critical alarm. But if you want to back it down a couple more amps just to get it within the 5, because that'll be the actual rating. So
let's try 88 amps. All right, so it's showing yellow, but it's showing 5 kilowatts. And we cleared it. It's not yellow anymore. Is that good, Chris?
That's good. And also, just to make sure that where voltage on the batteries don't rise too much, we have a inverter taking power off the system and going into a resistive load bank. So yeah, we've already dropped down. We're down at 98%.
Well, everybody, we're coming up on 2 hours and 20 minutes, which should be just about 1 gallon. So let's turn off our load. So it just ramped down a little bit. We'll let the generator cool off for a few minutes. Now it's a bit quieter because we shut off that generator. But we charged the battery for 2 hours and 20 minutes, which should be just around 1 gallon of use. So let's see what we did. We'll turn on the phone, which is connected through Bluetooth to the Victron Smart Shunt. And it says that we charged 10.6 kilowatt hours, which is really good if that's 1 gallon. But we now need to go measure how much fuel we add to the generator to see if it really was 1 gallon or not.
So I think we've used the fuel down.
So it looks like the fuel's right down here, right at the edge of the metal. So we need to fill it back up. And we can also come up here and take a look at 62% fuel, and we need to bring that up to 100%. Chris, do you know how large this fuel tank is?
Yeah, it's just under 4 gallons.
So 4 quarts is 1 gallon right there. It looks like we're just above that. Looks like 1 gallon to me.
Okay. We're not quite to the line yet, so it looks like we used a little more than 1 gallon.
Yeah. So this was consuming at a faster rate than we thought.
Right.
All right, that looks great for 1 quart.
All right.
So let's add that. And if we want to check the digital display, that display there says 92%. So we're still not at 100 and we're not back to our line yet.
Okay, here we go, more fuel.
So we're gonna try 1 more quart. All right, so we're still a little bit below the line.
You ready for me to add some more?
And we're showing 98%, so we need a little bit more fuel.
Okay. I'll just add a little drizzle at a time. You let me know when.
And this is still showing 99%. Okay, but I think we're at the line. But we still have about 1/8 of a quart left in this measuring cup.
Right, 0.875.
So 0.875, so we did 4.875 quarts. So we've added 1.2 gallons. If we divide it the correct way,
Yeah.
so we put 10.6 kilowatt hours into the battery. We used 1.21875 gallons, roughly. You know, we're eyeballing this as close as we can here. So that turns out to be about 8.7 kilowatt hours per gallon.
Right.
8.7. So 8.7 is better than anything I've tested at home. Definitely not as efficient as we thought it was going to be.
Yeah, just going by the paperwork.
Even taking into account the 10% loss in the charge inverter, we should have done better than that. Still, it seems like a big chunk.
Yeah, it does. I'm surprised it was that far off. So, you know, either they were being a little optimistic when they sold the generators to the military, or this unit may have maybe a timing issue or something like that that I haven't looked into yet.
Now, this is a naturally aspirated engine.
It is, yeah.
But we're not very high above sea level.
No, we're about 675 feet above sea level here.
So
it's
no,
it's not density.
okay.
It's a cool day, so we've got good density altitude, so there's
Yeah,
no real issue.
I think the weather report says something like 67 degrees Fahrenheit today.
Yeah, so I don't really think it's an environmental condition. I think it could just be something specific to this generator. It could even be the weight of the oil in it.
We still like this generator quite a bit, but getting 0.3 kilowatt hours per gallon better than an 802, when I think you said this generator runs for 2 to 3 times as much money?
Yeah, there's no ROI from a fuel economy standpoint to buy this versus the previous generation.
You won't be able to run this for long enough hours to justify that.
And the other parts is, you know, the cost difference for acquisition is one thing, but also when you do need to purchase parts for like repair or maintenance, this is a more expensive machine to
Oh, it is?
Yeah.
Okay. The 802 and 803 that have been long-standing for decades, that one has more parts available.
Well, yeah, and also the parts are cheaper.
I'm glad that we ran the test. Thank you so much for letting us use your generator for it.
Yeah.
Chris has a side business where he sells these generators. How can people get in contact with you if they want to buy one of these or one of the older model 802s or 803s?
Yeah, if anybody has any questions about these things, how they work, and want to get in touch, you can just email me at mepgenerators@pm.me.
Okay. Well, that's a lot to remember, but I will leave it in the description below. And if you guys enjoy these videos, please like, subscribe, comment, and share. So here's a little bonus material, everyone. Last night, Chris and I were trying to discuss why there was like a 22% or so discrepancy between what the manual's rated fuel economy was and what we saw in real life. So what was the first thing that we thought might be one of the contributing factors?
Yeah, we talked about the military rating this thing when it's in 3-phase mode versus single phase, how we tested it.
So these units are kind of neat that there's a physical switch inside here where you can rotate it between single phase and 3-phase. The stator head can do both.
Right.
But that means that we lose a little efficiency in single phase mode?
Yeah, you lose just a little bit because it does set up a little bit of circulating current in the head. It's not much, it's a few percent, but it is something that can be measured.
Okay. And so what kind of percentage are we talking there?
I'd probably say somewhere in the range of maybe up to 3%.
Okay. So we had a 22% discrepancy. We got 3% there. So now we're up to a 19% kind of explanation, maybe.
Yeah.
And we had a couple other reasons. What could be another one?
Yeah, so we talked about the fact that this unit has almost no hours on it. So it's really not broken in yet.
Oh, how many hours does it have?
So this one has like 60 hours on it.
60 hours. And what's the break-in period on these machines?
They call the full break-in period is like 200 hours on this.
200?
Yeah.
Okay. So we're definitely not at 200 hours yet.
No.
So breaking in the engine means the piston rings will mate better with the cylinder walls. And that's less friction, less blow-by.
Yeah.
And so what kind of percentage could we potentially be talking about there?
You know, that actually could be 5 to or more, up to maybe 10%.
Wow.
Yeah.
I never would have guessed that high.
Yeah, because until, you know, you really have everything polished up so that you reduce the friction in the bore, then yeah, this thing is actually working harder just to keep itself moving until the break-in period's finished.
Wow. Okay. I mean, it still maintained the 5 kilowatts just fine.
Yeah, I had no problem with that.
You know, that can account for a bit.
Yeah.
So maybe now we're down to 10% discrepancy. I don't know.
Yeah.
And then another one that I said was, you know, the measuring cup that I keep using repetitively for all these tests, it's not a calibrated volume measurement.
Right.
You know, I think it's pretty good. You know, but it's not a lab grade piece of equipment. So there could be a couple of percentage off in that.
Yeah, and I guess one of the things too that we would need to consider is even when we were using the CT in this to determine when we were at 5 kilowatts, it also has a a calibration factor that we didn't take into account. So we could have been technically producing more power.
I think we did a good job putting the fuel in because we had both our Sharpie mark and the what was the ultrasonic sensor?
Ultrasonic, yeah.
Anyways, that's some of the things that we were discussing. It does not account for all of the loss, but you know, if you guys have any ideas of other things that may have accounted for it, please let us know in the comments below. Hopefully the manual is not just lying to us.
Yeah, I'd be curious to know if anybody else has any thoughts or ideas on what the discrepancy could be.
Yeah, they are more efficient than the older version.
Yeah, definitely.
But as we saw, you know, not as good. But
didn't quite meet up to the documented standard.
Still nice units, and you know, thank you to Chris for letting us play around in his backyard here and test these different pieces of equipment for the videos. So thanks a lot for letting me come down and do this.
You're very welcome.
All right. Thanks, everybody. Bye.